All right, so the last thing I think we're going to talk about a polygon today. And we talked about what a polygon is, but we're going to talk about a specific polygon and a couple things about it. So let's talk about that. I'm just going to, oops. I'll tell you what, let's not do that. It doesn't matter. I'll just do the one that I did in the other class just to be consistent. So there we go. All right, so here's a polygon. How many sides does this polygon have? 5 sides. So what's it named? So what? Hexa? Is hexa 5? What's 5? What is it? It's in Washington, D.C. What's that big building in Washington, D.C.? It's a pentagon. Okay, it's a pentagon. Let's see what I want to do. Okay, let's do this. Let's just name it. Let's go A, B, C, D, and E. So we didn't talk about this yesterday. This is right where we left off. We want to name this polygon. If I asked you to name the polygon, you could actually name it several different ways. All right, you could call it polygon, or you could call it pentagon. Since you know there's 5 sides, you actually could call it pentagon. But what I'm concerned about, I'll just call it polygon. We'll just be real general. Okay, we'll call it polygon. Now we can start at any letter that you want. All right, doesn't matter which letter. Okay, as long as it's a vertex on this polygon. Let's just start at A, make it easy. Okay, I can start it at one point. It doesn't matter what point. It doesn't have to be the first letter of the alphabet. It doesn't have to go in alphabetical order. It doesn't have to be at the top or anything like that. You could pick any point. But here's what you need to do. You need to go in consecutive order. You hear that word consecutive? That means one right after the other, which means you can't skip around. You cannot do this. You cannot call this polygon A, D, C, E, B. Did you watch? Did you follow the pen? All right. You can't do that. So what do you think you could call this? A what? A, not just A, B. You're going to use all the sides, all the vertices. A, B, C, D, E. That's right. So I could call this polygon A, B, C, D, E. Okay. Or what's another way I could call it if I start at point A? You got it. I could go the other way. Just make sure that you go in order. Okay. Go in consecutive order. So I could go A, E, what? D, C, B. So let's write that down. Polygon A, E, D, C, B. Now there's a lot of different variations. I could have started at point C, couldn't I? But what would I call it if I started at point C? I could go this way. I could call it C, B, A, E, D. Okay, or it could go the other way. I could call it what? C, what? I'm waiting. C what? C, D, E, A, B. Very good. Okay, just to see that you're playing along here. That's all I want. You could call it polygon A, B, C, D, E, or you could call it pentagon A, B, C, D, E. It doesn't matter. I don't think they really care. All right? Everybody with me? You just can't skip around. You can't go E, B. You can't do that because that would not be consecutive. You could go E, A, or you could go E, D and go around. All right? So there's a bunch of different ways that you could name this thing. All right? We're not going to write down them all. That would take too long. Everybody okay with that? All right. Let's do another word. A lot of this lesson, not all of it, but a lot of this lesson is just vocab. We are going to do a little bit of math in this lesson, okay, just a tiny bit, but we are going to do a little math. The stuff that we're going to learn right now with this particular word is stuff that we're going to do later on, and we are going to do some math with it, okay, but not in this chapter, all right? So this is just learning the word, and then when you get to the next chapter, I don't know what chapter it is, maybe the next chapter, we're going to actually use it, put it into practice, and we're going to actually put some numbers in there and figure out some math stuff, all right? So what if I started at any point? I don't care what point you start at. Let's just start at A. And what if I wanted to connect, make a line segment that connects this vertex, listen to this word, a non-consecutive vertex. We talked about consecutive, right? A, B, C, D, E. They're all consecutive. There's one right after another in a row. Well, what if I went from here to a non-consecutive vertex? Where could I go? From A to what? A to D, good. That's a non-consecutive. It's not right after the A. What would be right after the A? Either B or E, good. All right, so this would be non-consecutive. Starting from A again, is there another vertex that's a non-consecutive? Yes, C. I could start at A and I could go to C. Everybody got me there? So we give these things names, all right? This thing, when I go from one vertex to a non-consecutive vertex, you know what that means, right? The one that's not right next to it. For instance, if I started at A and I went to E, is that a non-consecutive vertex? No, that would be a what? Consecutive, all right? Because it's right next to it. Or A to B, that would be consecutive. So this would not be the word that we're going to talk about, okay? But these two are, and we call these diagonals. You've heard that word diagonal many times before, but probably not in this context, all right? So these are called diagonals. That's a diagonal, line segment AD. So if it said, list the diagonals, I don't think they do, but if they did, you would say line segment AD, because it starts here and it ends here. And what's another diagonal? Line segment what? AC, right. So if I ask you for the diagonals are always written as a line segment, because they don't keep going. Starts and stops. All right, there's a bunch. Did I have to start at point A to find the diagonals? No. I could have started at E, and I could have, let's just do different colors so it doesn't get mixed up. What's another way to write a diagonal? From E to what? E to B is a diagonal, and from E to C. That'd be another diagonal. Could I go from E to D? No, because it's right next to it. I go to the ones that are not next to it. And I could keep doing this for all the points if I wanted to, but a diagonal starts at one vertex and it goes to a non-consecutive vertex. All right. We're going to be doing a lot of stuff with that later on. In fact, let me just give you a sneak preview. There's going to be, and I think it's the next chapter, I'm not exactly sure, but it's not too far from here. If I say this is a regular, what does that mean? A regular pentagon. That means all the what? We did this yesterday. All the what? All the sides are equal and all the angles are equal, okay? All the sides are equal and all the angles are equal, all right? So if I have a regular pentagon...
Can I have Caitlin Jones and Caleb Wall for guidance, please?
So if I have a regular pentagon in another chapter, I think it's the next one, I'm not really sure, but we're going to be able to figure out exactly what that angle measure is, actually the number of the angle, all right, how many degrees it is. Okay, we're going to be able to figure that out, okay, mathematically using diagonals, all right? So we are going to use diagonals. It's very important that you know what they are. So when we get to that point, I'll say, hey, remember back when we first learned diagonals, we said we were going to use it? Well, here we are. We're using it, okay? That's what's going to happen. All right, let's keep going. Let's talk about a triangle this time. We talked about triangles earlier. So I'm just going to draw some kind of random triangle. Doesn't matter. Nothing special about it. It's not equilateral, not equiangular. It's just regular old triangle. All right? And let's put some points on here. We'll call that A, we'll call that B, we'll call that C. What I'm going to do is talk about this word, opposite. Everybody knows what opposite is. But I'm going to talk about opposite sides compared to opposite angles. So opposite sides and angles. Just put a comma in between there. Right? What am I talking about when I talk about something being opposite inside a polygon? Now I just drew a triangle here, but this would work for any polygon. Well, not necessarily. Works for a triangle. Okay, let's just say that. Works for a triangle. Let's change colors. All right, what if I said, first of all, we talked about this yesterday. What three angles do I have? Angles what? Real easy. A, B, and C. Yeah, it's easy. The one that's maybe a little bit more difficult, not much, are the sides. Let's name the sides. A what? Line segment AB, that's a side. What else? What's another side? Line segment AC and line segment BC. Good. Those are my three sides. We talked about what sides were yesterday. All right. What I'm going to do is talk about which angle is opposite which side. So let's start with angle A. What if I without even me telling you what an opposite side was, you probably could guess what it is. What do you think is the opposite side of angle A? I can't just say C because that's not a side. Mario, what is it? BC, line segment BC, or side. You could say side or line segment BC, all right? So I like to draw an arrow. So those are opposite each other. You see it? Because BC doesn't have A in it at all, does it? All right, that means it's completely opposite. If I said BC was opposite angle B, that doesn't make sense because angle B and BC, they share letter B, don't they? They share something. So they're not opposite each other. Well, BC does not share A, does it? All right, so it's opposite angle A. All right, we'll do this in colors, make it a little easier. What if I asked you what is opposite angle B? AC. That's right. See how it's opposite? It's across from it, if you want to say that. But we don't really say across. We say opposite. Still got heads down. I'm really close to sending everybody with their head down to Mr. Serac. And you can sleep in there. Somehow I don't think he'll let you sleep in his office, though. Okay? He'll have you doing something else. All right? So what's opposite angle C? Angle, or not angle, side what? AB. Or line what? Segment AB. That's right. Okay? Everybody with me on that? In the last class, I kind of wrote them down. I said angle A is opposite line segment BC. And I did that for all three of them. But I put all these arrows there. So that's good enough. Everybody understand that? Again, for the 100th time, we're going to see this later on. Okay? They're going to say, they're going to have theorems and postulates and stuff. And they're going to talk about sides being opposite angles. All right? So you're going to have to know what it means. That's why we're doing it right now. So later on, you'll know what it's talking about. All right, let's do another thing. Let's do this. Turn out white. You probably heard this word before. It's perimeter. I don't usually write a whole lot of definitions down, but I'm going to this because it's pretty short. It's pretty easy. So the perimeter of something. If I ask you to walk the perimeter, right? Has anybody ever heard that before? If I ran cross country, any cross country people in here? If you ran the perimeter of the property, what are you doing? Are you running right through the middle of it? No, what are you doing? Around it, around the outside of it. Exactly right, around it. So the perimeter is the distance around. Sometimes I just stop right there. I say, what's the perimeter? It's just the distance around. The distance around what? The distance around anything, all right? But in geometry, they say a closed figure, around a closed figure. All right? And our campus is closed in, right? It's closed in between the houses and the road and the whatever's back behind us, okay? But it's a closed figure, so if you wanted to run the perimeter of the campus, you would run around the outside of it. That's what it means. The perimeter, you're going around the outside of a closed figure, all right? So what if, I'll just do a triangle. Again, I'm just doing some random triangle. Seems like my random triangles all look the same. I don't know why. I should mix them up a little bit. We'll call it XYZ. Tired of using A, B, and C all the time. All right. And what if I gave you some measurements? What if I told you the lengths of these? What if I said that was like 3 feet? And this was, I don't know, 5 feet. And we'll say this was 8 feet. And I asked you, maybe it's on the homework, maybe it's on a quiz or a test, I don't know. But if I said, find the perimeter oh, you know what I forgot to tell you too? Is how to name a triangle. Did I have a triangle up here? What if I asked you to name this triangle? What do you think I would use to name the triangle? Probably those 3 points, wouldn't you? Okay, does it matter? Do you think it matters what order you put the points in? No, but we have a symbol for triangle, and it looks like a little triangle, just like that. So what would you call this triangle? Yeah, that's what I would call it, triangle ABC. Does it have to be triangle ABC? No, you could call it triangle what? BCA or BAC or CAB or CBA, right? There's a bunch of ways you could call that triangle. Doesn't matter, right? But that's the symbol right there for what? For triangle. Okay. I meant to do that earlier. Now we can go back to this. So it's going to say, find the perimeter of triangle XYZ. All right, you could see a problem very similar to this. Everybody got it? So what does it mean to find the perimeter? Find the distance around the whole thing. Exactly right. That's exactly right. You just add up the three sides. All right, so let's do it. Let's go 3 plus 5 plus 8 equals 16. But here's how I want to write my answer. Don't just write 16 and circle it. Everybody hear me? Okay. Write what you found. What did you just find? You found the what? You found the perimeter. Right. So I'm going to put just P. You can put just P for perimeter. Equals what? 16 what? Feet. That's right. So put the units there. All right. Just 16 doesn't mean anything. This is 16 feet. And then in the answer, it shows you what you found. You found the perimeter. All right, so put P equals 16 feet. We good with that? Yeah, let's do another example. Let's go 6 sides instead of 5. We've done 5 already, so let's do 6. All right. Now, I did this on the computer. All the sides are equal, all the angles are equal. We've already said this once today. What is it? It's a what kind of it's a hexagon. There's 6 sides. What kind of hexagon though? All the sides are equal, all the angles are equal. We said it earlier today. It's a regular polygon. That's right. In this case, it's a what? 6 sides means it's a hexagon. Very good. All right. Just trying to remember that. What if I said that that's 5? I'm not putting in units on this one. So if all the sides are the same, I'll make them all 5, just like that. And I ask you, what do you think I'm going to ask you to do? Find the what? Find the perimeter. I'll just put P. Is that all right? So you could do it one or two ways. One way is way easier than the other way. That's right. Each side is 5, right? Each side is 5. And then how many sides do we actually have? We got 6 of them. So what am I going to do? 5 times 6, which is 30. So my answer, how do I write it? P equals 30. There's no units on this one, so there's no units on this. All right? Some teachers say if you don't have units, put the word 30 units. Okay? I don't care. All right? If you want to put units, that's fine. Now, what if it was in, I don't know, inches? Then your answer would be, obviously, in inches. Okay? All right. But if it doesn't have any units at all, you don't even have to write the word units. Just write 30. That's fine. But write the P in front of it so I know what you're finding. That's pretty easy, isn't it? What's another way I could find the perimeter of this? It would be a little bit more tedious. Yeah, just add them all up. So I'd go what? 5 plus 5 plus 5. How many are there? 6? That's 4. That's 5. And that's 6. All right, I could do that. But by the time I finished writing all that, I could have figured out what the answer was anyway, couldn't I? All right, so you could do that if you wanted to. But this is so much better. They give you a little formula. I'm going to show you what the formula is. I don't really care that you use the formula because I think you can see it already. But here's what they do. They go P equals, P obviously means what? Perimeter, okay? Now they give you 2 letters and that may not be so easy to figure out what means what. But this means the number of sides and the S represents the length of each side. Okay? So you could memorize that formula. Is there really any reason to do that? I don't think so. And this only works when you have a regular polygon, by the way. Right? So if you just see that all the sides are exactly the same, I think you don't even have to think about this formula. Would you agree? You just know. You just multiply it by how many you got. All right? There's 6 of them. 5 times 6, 30. Boom, you're done. That's the way I would do it. Yes, sir. It could be. I don't know off the top of my head. Haven't looked at the quiz since last year, so I don't know. There could be. It could be. All right. I mean, it's definitely something that I could see being on a quiz. All right, let's do this. Let's go from all these things back to circles again. We talked about circles yesterday briefly, so we're going to get into it a little bit more today. Again, this is, for the most part, it's just learning vocab words. But there is a little bit of math on this. Remember I said at the beginning of class, we're going to do a little bit of math. We will, but we got to do some of these words first. All right, let me draw this. What I'm going to do, the first word is if I'm going to connect one point on the circle to another point on the circle. Okay, they could be anywhere on the circle. They could have been super close to each other. They could be directly across from each other. But if I connect one point on the circle to another point on the circle, we have a name for that. And we call that a chord. C-H-O-R-D. There's an H in this. Kind of like, was that? Oh, was that on the homework? Okay. All right. So we didn't get to some of the stuff that the homework was on. So you could probably finish it tonight if you needed to. All right, because I'm going to collect it tomorrow anyway. All right, so chord, that's what that is. What is a chord? It connects 2 points where? On the circle. All right, thanks for playing along. All right, what's this thing in the middle right here, that little white dot? What does that represent? Represents the center, okay? So let's do another color. What if I drew a chord? I'm going to draw another chord, but this is going to be a specific type of chord, a special type of chord. And it's a chord that goes through the center of the circle. See, that would be a chord, wouldn't it, right there? But is that my special chord? No, what's the special chord? It goes through the what? Through the center. We have a name for that. And I bet you some of you guys know what that name is. What is that? It's the diameter. That's very good. Okay, so it's the diameter. That's the diameter of the circle. So what's a diameter? It's a chord, isn't it? Is every chord a diameter? No, that red one's not a diameter. Why not? That red one's doesn't go through the center. That's right. A diameter has to go through the center, and it's got to connect 2 points on the circle. Everybody with me? Yeah? Got people knocked out, man. I'm telling you. I should, I think my math videos would be better than they, don't they sell these things with like soothing sounds and stuff like that, rivers and creeks and stuff like that, the ocean crashing, right, to put you to sleep. I should put my videos out there. Watch Mr. Hammy's math class. It'll put you to sleep like that. Here's proof. There's 5 people in my room with their head down on their desk. I don't know. But it's not. So here we go. Here's another one. Watch this. So we got chord, we got diameter. Here's another word. What do you think we're missing right now? Okay, we are going to do. You're looking ahead, aren't you? All right. But just looking at this stuff, when you talk about diameter, you got to also talk about something else. What do you think? And again, I know you've seen this before. Radius. It's a radius. Okay, what in the world is a radius? Well, I'll tell you what. Let's draw it out to here. It doesn't matter. So what's a radius? It starts where? At the center, okay, and it goes to any point on the circle. Doesn't matter where, all right? It goes to any point on the circle. So it's a line segment again, okay, but one of the endpoints of the line segment is the center of the circle. Does it go all the way through? No. Is this a chord? Is the yellow one a chord? Probably. Why not? It doesn't connect 2 points on the circle, okay? The center is not on the circle. You got it? Only the stuff on that white right there is the circle. Okay, so this does not connect 2 points on the circle. So is the yellow one a chord? No. What is it? It's a radius. Yeah, Owen.
I think in homework they said that diameter is also a chord.
It is. We said that earlier. Yeah, because I said it's a special type of a chord. Remember that? Okay, so it's a special type of a chord, the diameter is, but the radius is not. But there is a relationship between the diameter and the radius. Even though they're not both chords, there's definitely a relationship. Because look, I'm going to do this in yellow again. What if I started at the center and went to this point on the circle? That's also a radius, isn't it? Tell me the relationship between the radius and the diameter. Well, they both go to the center, but watch. That one goes to here as well, right? So what's that? I didn't draw very straight, but what's this yellow one and this yellow one together? This radius and this radius together is the diameter, right? So it's half of it, exactly right. That's what I was looking for. All right, so the radius, watch. The radius is equal to what? Half the what? Diameter. And a lot of times we use a capital D for diameter and a little r for radius. It doesn't matter. It doesn't have to be that, but a lot of times that's what they do. Or you could look at it the other way. You could say the diameter is how much of the radius. No, it's not half. The diameter is not half of the radius. The diameter is how many of these radii, right? That's plural for radius. How many of the radii would make up one diameter? 2 of them, right? So the diameter is what? 2 times the radius, okay? So the diameter is twice the radius, or the other way around, the radius is half the diameter. All right, that's really important. This thing right here, I would remember that. Okay, that one's really, really important because of what we're going to do in a minute. But we got one more thing to talk about. And you guys cheated and looked, but that's okay. That's a good kind of cheating. I don't mind that kind of cheating. Let's do a different color. Let's go pink. All right, watch this. What if I connect 2 points on the circle, but not a straight line? What if I actually go around the circle to connect those 2 points? Like from here to there. That's close. I missed a little bit, but you get the idea, right? So what if I connected this point to this point? Is that a chord? I'm connecting 2 points on a circle, but this time I'm going around the outside of the circle. I'm not going through it. It's not a straight line. This is a curved line. And you guys have already said it, and it's called an arc. We're going to be doing a lot with arcs later on. Not too much in this chapter at all. We're just learn what it is. Later on, we're going to do a lot of stuff with arcs, believe me. Almost a whole chapter. When we do the circles, we do a ton of stuff with arcs. We're just learning what it is right now. That's all we're doing, okay? And we have a way to label it like we do for everything, don't we? So let's call this AB. And if I wanted to call this arc AB, here's what I would do. I'd put an AB. I don't write the word arc in front of it. We got a little symbol for it. And it looks like this little curved thing on top. Right? It should be a little bit more rounded. There you go. That means what? Arc AB. And what does it mean? It means you're going from A to B, but you're going around the circle. You're not going through it. Is this right there that I just drew, is that an arc? No, there's a big difference between arc AB and chord AB or line segment AB. Are they the same thing? No. Which one is a longer line? What if I took that arc and I stretched it out? Okay, which would be a longer distance? If I wanted to walk from A to B, what would be the shorter distance? Let's do that. What would be the shorter distance? It'd be a straight line. You ever hear that? The shortest distance between 2 points is a what? Straight line. That's a basic geometry concept that we use all the time. Real quick, if you're taking notes, put your hand up. Quick. Okay. Thanks. All right, let's talk another word. This kind of is this word right here, perimeter. But perimeter, we usually use for the perimeter of like straight stuff, straight sides, all right? A circle is not straight, it's curved. So we have another word for it. We got a different word for the perimeter of a circle. Now the perimeter of a circle just means the distance around the whole thing. We got another word for that. You probably heard this before. It's called the what? Circumference. That shouldn't be new to you. If it is, it's fine. There it is, right there. The circumference of the circle. That means the same thing as the perimeter of the circle, the distance around the circle. Right? So if I started at A and I walked, okay, or drew my pencil or pen all the way around the circle and I ended back up at A, everybody see that? I went all the way around. That's the circumference of the circle. All right? We actually have a formula for this. We'll use C for circumference, and we're going to introduce a number that you probably heard before. I'm not going to get really into it because of time constraints. Normally I would. Maybe another day I will, but not today. Here's, let's do it like this. 2 pi r. All right? That's one that you should memorize. That's absolutely one you should memorize. Circumference equals 2 pi r. What in the world's pi? Never even mentioned pi all year. But you probably already know what it is, right? Because you've done this before. Pi, actually, I shouldn't put equals. I'm going to put approximately. You see the 2 squiggles? That's not congruent. That means approximately equal to 3.14. It actually keeps on going, technically. I could put dots right there. It doesn't repeat, okay? It doesn't repeat anything. Once in a while, it might repeat one number, but it doesn't repeat a pattern, all right? It never repeats a pattern. I used to have a poster in my room, not in this school, because it ripped before I got to this school. But I taught at another school for 17 years before I came here, and it went maybe 3/4 of the way around. It didn't go all the way around the room, but it had pi to like over 100 decimal places, and it was 3.14159 whatever. It goes on and on and on. That's all I got memorized, up to 159. But then at the very, very end, it had these 3 dots. What does those 3 dots mean? Just keeps going. That's right. It just keeps going. All right. It doesn't repeat a pattern, but it just keeps going. As far as we're concerned, I'm only using the 2 decimals. All right. You have a button on your calculator, a pi button. All right. And don't use it because it'll take it out to like 6, 7, 8, depending on your calculator, right? A bunch of decimal places. You don't need that number. So that we're consistent, just use what? 3.14. All right? Everybody got that? So this pi and what's pi? Why is that a pi? And you spell it just P-I. It's not P-I-E like a pumpkin pie. All right? It's just P-I. It's a Greek letter of the alphabet. All right? The Greeks have their alphabet, just like we have an alphabet, and it's one of the letters in their alphabet. And that's what we use. We just use a Greek letter. It just kind of stands out a little bit more instead of using P, because P could mean what? Perimeter. So pi, we use a Greek letter of the alphabet for that. Okay? All right, enough of pi. There's more that I could talk about pi, and I would love to, and it's pretty interesting, but I'm not going to right now. So here's another thing. Do you see this D equals 2R? Well, check this out. I got a 2 and an R right there, don't I? So here's another way. I'm going to put an or. Or you could write it like this. Instead of 2R, what's 2R equal to? D, right. So I could write pi times D. So I could write it either way. Because what's the diameter? It's twice the radius, isn't it? All right, so instead of writing diameter, I could write 2R. The reason I put the 2 in front is because we always put the number out in front when we have variables or Greek letters and stuff like that. All right, let's do an example and we'll be done. So, I'll tell you what, let's just copy and paste that. Scooch it a little bit. Stop the tapping, please. I thought it would stop by now, but... All right, this is an example. So it's example 5. It's in the book. And let me put the center here. Oops. Right there. And I'm going to draw this. What did I just draw right there? That's the radius. I'll just put R for radius. And here's what the book tells you. Here's what the example tells you. They tell you the circumference. They don't tell you the radius. So that makes it a little bit more difficult when they tell you the circumference. If they tell you the radius, to find the circumference is really easy. All right? But when they tell you the circumference, it's a little tougher. So let's write an equation down, a formula down that we just learned like 2 minutes ago. All right? What's a formula that has circumference and radius in it? Look at your notes. You got it. 2 pi r. Very good. All right, so C equals 2 pi r. So what do we know here? This is what they tell you. Okay, they don't tell you the radius. I'm going to put equals question mark because that's what you want to find. All right, they tell you the circumference though, don't they? So what are we going to do? Put in a 10 in for circumference equals 2. I'm just going to leave this pi for right now. We'll do the 3.4 at the very, very end. Okay, and then times r. R is what I'm trying to find, isn't it? That's the variable. So let's do some algebra. This is why we did algebra at the beginning of the year. Let's get r by itself. So we got to get rid of the 2 and we got to get rid of the pi. They're being multiplied, so how do I get rid of it? No, not minus. They're being multiplied. What's the opposite of multiplication? It's divide. Divide by 2 pi. They'll cancel out. Then I come over here and do what? Divide by 2 pi. So look, those cancel, so r equals, you could do this if you wanted to, just make it a little bit easier for you. 2 goes into 10 how many times? 5. So what is this? This is 5, not 5 pi. Where is the pi? It's on the denominator, right? It's on the bottom. So we don't write 5 pi, we write 5 what? Over pi. 5 over pi. Because look where pi is. It's in the denominator. We're dividing by pi. Now you can put this into your calculator. I'm going to put in a little approximate symbol. I can't do that in my head. I would definitely need a calculator to do it. So I did it already, and it's 1.59. This is in centimeters, so what's my answer in? Centimeters. So, but how am I going to write my answer? I want to write r is approximately equal to 1.59 centimeters. And that's what you would circle right there. They do have a part B to this. It's way easier than part A. I did the harder one first. All right, so today, your homework is 31 to 43. It's still same section, but it's 16B. You're doing 31 to 43. And if there were some on the other ones where you had arc and stuff on there you couldn't do, you can finish those up now too. Okay, you probably were able to do most of the stuff from last night's homework, but today you should be able to get it all done. Ready for tomorrow. We'll have a big question and answer day tomorrow. We'll have a review for a quiz tomorrow, and we won't have any homework tomorrow. Okay, so get it done tonight, and I'll see you tomorrow.